Alright, so this is coding lab 4. Um, the first function, Bayes, computes probability of B given A provided the values of probability of B. Joint probability of A given B has occurred. Probability of B not occurring. Probability of joint probability of A given that B has not occurred. These are all just representative values of things that are in the function on the right of the equal sign. The output is going to be the probability of B given A. This is your arguments into the function. This is just giving joint probability of B and A given that B has occurred. This one is just joint probability of B not and A given B not. So this is going to be return value here. This is basically a working code version of the theorem where you have the joint probability of B and A up here divided by the joint probability of B and A plus, joint probability of B and A given B, and plus the probability of B not, joint probability of B not and A given B not here. It's going to return this probability of B given A. You can run these, get the expected values here, match with these. So the second function is the expected value function. Takes two arguments, outcomes, which is a list containing outcome values, and probability, which is a corresponding list containing the probabilities of this outcome values in the first list. The output is going to be expected value. It's either going to be a number or it's going to evaluate to false if the probabilities don't add up to 1. So this is our function here. The sum is going to be keeping track of the probability values and the probability argument given in the list, I should say. Expected values is going to keep a running total of the expected values as we're multiplying the outcomes and probabilities. This first loop here checks for the probability. Well, it doesn't check. Actually, it doesn't check for anything. It just adds up all the probability values, and then this if statement here checks to make sure that those are valued to 1. If not, we get a false evaluation. If we do have 1 for probability, then we run this for loop here, which the zip function pairs the index values of these lists, and then this is just to iterate through the lists. And then the expected value is just running this is keeping a running total of outcomes times probability, which will give you your expected value. So we're getting these. I already ran them. I don't know. I feel like run them again. So these all match up with these values up here. Okay, this one. So the move function takes some arguments. X position and Y position is the coordinates of the player. The distance is the amount it should change for key press, and the grid is the grid of the current game. Outputs the new position. It's a tuple. It's a X and Y coordinate. Also, grid size is the size of the grid, obviously, and the square number is how many squares you want in each row and column. So it'll divide the grid up evenly. So we start by coming up with a square size, which is going to be your grid size divided by square number. So like in our case, I think it's 600 by 10, so each square is 60 by 60. We define the top left, top right, and bottom right corner points here. Obviously top left is just xy, bottom left is x position plus, x position, y position plus the square size because you want the bottom value, and our grid is positive in the down and right directions. Top right is the same, except for you're going to have x position plus square size to get to the right corner, and y position is still the same. And then Bottom right is going to be X position plus square size and Y position plus square size to get to the bottom right corner. So it's those. These are just to offset the values by, like, obviously 0.001, but it's to prevent unintended overlap in the corners or edges of the player and either the boundaries or the barriers. So this way there's no unintended interactions where you might have like a player up against, or not up against the wall, or up against the wall but it won't let you move because you're on top of the wall, something like that. Just to make sure that doesn't happen. So first if statement is pretty self-explanatory. It just checks for the key press. This one's left. Second if statement checks for it checks to make sure that you're within the boundary of the grid. So then if you are within boundary of the grid, then it comes through here and it checks to see what your next distance would be after the key press. And then once it figures out what your distance would be, or sorry, not your distance, but your position after the key press would be, it checks to see if that distance would be coming in contact with a barrier. If it is, then obviously it won't change your distance, but if it passes all three of these checks here, then you increment the distance by the distance value. All these are structured the same way. The only thing is we noticed that for the X position and Y position, they are grabbing the top left corner of the square, which was fine for movement off the grid in the left direction and going up because it was grabbing those values, but it caused a problem when you were moving out of bounds going right or down, because it was checking to see like, oh, your position is Y position or X position, but it was grabbing a top left corner which was not in contact with the edge of the barrier. So according to the code it was saying, oh, you're free to move, but then when you did move it would throw an index out of bounds error. So that we fixed that by just adding the square size in this if check to make sure that we were grabbing a X position and Y position that were corresponding to corner points that would be coming in contact with the edge of the map. So let me run these just so I can show the move function here. That's not, okay. Alright, so you can't see this, but I'm trying to go left and I'm trying to go up. It won't let me go right either because I'm in contact with the barrier. So now we're going to test some more barriers here. Can't move. Well, let me move down past this one. We're going to check the edge, the left and right, or sorry, the right and the bottom. I can't move through that. Can't move through that. Can't move out of bounds here. Can't move out of bounds here. Then we'll just check the right barrier movement here. Can't move past that. We'll check up. Alright, cool. And that's the move function. That should be everything.